AP Calculus, video part 4. AP Calculus, it's about definition of derivatives. Let's do last thing we did number 8, I think so, no, not 8, we did number 12. Number 13 is the same. Let me just give you the derivative and you can do it. Number 13, let's say f prime of x is equal to 5. It's constant number, we leave it. We multiply with radical 2x, only the derivative of radical 2x, and we multiply it with the derivative of 5, with the constant number 5. So it's 5. What is radical u? Derivative of radical u. It's u prime. It's the derivative of the thing inside, right? Over 2 radical u, which is this. So we cancel the 2. We left up with 5 over radical 2x. Now, what is f prime of at 8? He wants me to find it, so I have to replace 8 instead of x. 5 over radical 2 times 8, 16. The answer is 5 over 4. I will leave you for you to do it by definition yourself. Okay, so let me erase here and continue. Let's start with number 14. Number 14 is about y equal, or f of x equals sine x at x equal pi over 3. We know the derivative of sine x is cosine x, and we replace pi over 3. What is cosine pi divided by 3? Pi divided by 3, it's 180 divided by 360, and cosine 60 is half. So let me do it by definition. It's equal to limit as h tends to 0. What is this? It's f of, it's let me replace directly instead of x, x1 plus h, it's sine x1 plus h minus sine x1, right, over h. We have rules here, okay, of trigonometry. You can also review the trigonometries. I have some parts in trigonometry. I didn't do this rule yet, but I will do it. What is sine x plus h equals to? It's sine a plus b, right? What is sine a plus b equals to? It's sine a cosine b, right? It's sine a cosine b plus sine b. This is not b, this is h actually, right? Plus sine b cosine. Let me do it again. It's sine a, yeah, it's true, sine a. What a here is x1 cosine b cosine h plus sine h cosine x1 minus sine x1, right? Minus sine x1 over h. What we have to do here is, okay, I think so the best way here to do is to replace directly f prime of pi over 3. Let us use directly the f the point pi over 3. It will be much easier for you. Otherwise, if you don't want to do that, we can continue if you want doing the derivative. Let me find the derivative in case we don't have a certain point, right? So it's limit as h tends to 0, right? As h tends to 0 of let's try to take common sine x1 between this one and this one here, right? What we left up with, sine x1 into cosine h minus 1, right? Plus, let me take it over h alone, plus limit as h tends to 0 of sine h times cosine x1 over h, right? Which is equal. Sine x1, we can take it outside because x1 here represents a point. It's not x, it's x1, right? Times limit as h tends to 0 of cosine h minus 1 over h plus also cosine x1 here is a point, right? Is a number, is a constant, I mean. It's not a point, it's constant number as h tends to 0 of sine h over h. If we replace 0 instead of h here, cosine 0 is 1, 1 minus 1, 0 over 0. So we also have a problem. But we have this as a rule, right? What is cosine h over h as h tends to 0? This is a property we took before. Limit of cosine h over h as h tends to 0 is directly 0. We can replace it directly 0. We proved that in some videos before. I think so in the limits videos, chapter 1 AP calculus, we proved that this will be equal to 0. We multiplied with cosine h plus 1 over cosine h plus 1 and blah blah blah. We finished you can go back to some videos limits and you will see that this is 0. It makes all this product 0. So we left off with only cosine x1, right, times the limit of this. And also we have this as rule, it's 1. And I will do this activity to make sure that how we found limit of sine h over h as h tends to 0 equal to 1. So we end up with only cosine x1. Now, if we want to find the f prime of pi over 3, this means we're replacing instead of x1 its value, cosine pi over 3, and cosine pi over 3 is simply half, right? It's half. Cosine 60. So yeah, sine 30 is half, so cosine 60 is also half. This is it. Let me see if we have another one. This is number, if we can do another one fast. This is, yeah, this is number 14. The final answer will be equal to half, right? Let me see number 15. The same thing. Number 15, we have cosine. We need to find the derivative of cosine without any point. Let me see if we can do it fast. This is number 15. So it's the derivative, right, at x1 is equal. It will be minus sign at the end, minus sine x. It's the limit as h tends to 0 of f of x1 plus h, means cosine x1 plus h minus cosine x1 over h. So this will be equal to limit as h tends to 0 of what is cosine x1 plus h? It's cosine a plus b. It's cosine a cosine b minus sine a sine b. Sine x1 sine h minus cosine x1. Here we do the same thing, but we take common factor cosine x1 between the first term and the third term. F prime of x1 is equal to limit as h tends to 0 of cosine x1 common. What left is cosine h minus 1 over h minus sine x1 sine h, right? Which is equal cosine limit of cosine x1 into cosine h minus 1 over h minus limit of sine x1 sine h over h when h tends approaches 0. It is equal to, let's take cosine x1 outside as a constant number. It's cosine x1 times limit as h tends to 0 approaches 0 here too of cosine h minus 1 over h minus limit as h tends to 0. Okay, first let me take the sine x1 outside times the limit as h tends to 0 of sine h over h. Again, this is 1 and this is 0. We end up with minus sine x1. This is the derivative of cosine x. Continue next video.